Hello, I'm playing with junk again. This time I have a Kodak Direct View CR975. It's a X-ray cassette scanner. So basically it takes X-ray pictures and digitizes them by scanning them with a laser. And well, how this works I will explain a little bit later in this video. Let's see what's inside and take it apart. This unit uses special cartridges, which are not film but some kind of phosphor coated plates, and for scanning you place them here and here. There is place for 8 cartridges, and then the conveyor belt pulls them over to here where they go down into the slot and then will be stored here in the output area. I'm sorry I don't have original cassettes here. I only have 2 wood panels, but that's to illustrate how this works. The other question is, why do we have this machine anyway? So what is it good for? Let's say you have a traditional X-ray machine. Let's say that's our X-ray tube here. That's you or parts of your body, and behind that will be a film. You get X-rayed, the film gets exposed to the X-ray and then goes to a developer machine and turns out as a picture of your skull and bones. You know that. It's what the doctor hangs on the wall with a light bulb here behind to see everything, or you can take it home after when everything is over. Nowadays it is important to have everything digital, so you could of course scan that, but you need a special scanner and with a high resolution and something to get your big picture in. So the Kodak machine here replaces this developer and scanner process. So instead of a film, you have this phosphor screen. It works like a film, but there is one difference: you can erase it. And use it again. And you don't need a developer with chemicals. You only need the scanner, which I'll show you then. And yeah, that's it. Now the principle here of this storage phosphor screen as they call it, it stores the X-ray picture in some kind of luminescent whatever, and then you need a red laser with a mirror here that moves the laser sideways. Yes, sideways. Okay. And then the entire screen here is moved down into the machine. And when it is hit with red laser light, it will emit blue light, visible blue light, but very weak. So to catch this blue light as the laser scans, we have some photomultipliers. They could also be here, for example with the lens. And we need, of course, a filter to let the blue light pass, but not the laser. The Photomultiplier Tube, PMT, goes then to an amplifier and some kind of digitizer, and then to a PC, which is inside the machine with the screen. Yeah, that's about how it works. So it is intended for people who already have an X-ray machine but want to go digital without changing the entire machine here, so you can keep your existing X-ray. You only have to change your film for a phosphor screen, and then you have to buy, of course, that Kodak machine that does all the rest. So how is this entire thing working? So I prepared a piece of plastic which I sprayed with glow-in-the-dark paint. That's that kind of paint that reacts to UV light. I have here a little UV light laser pointer, torch, whatever. Well, it works like that. So just imagine this is an X-ray machine, and I want to X-ray my hand. So I expose it to X-rays with this film here, or better this phosphor screen inside the cassette, and I get an image of that. With these phosphor screens, the image is not visible with the naked eye. Then I put it in the scanner, and it scans it with the red laser. And the special phosphor here in these cassettes emits blue light when it is hit with a red laser. It's a bit strange, but that's what happens. And the intensity of the blue light then depends on how much X-ray radiation that part of the screen has got. And then, when everything is scanned, you take a white light, erase the entire area, and you can use that phosphor screen again. Now let's see inside. There's a big door. The big empty space here was once filled with a PC and a UPS. This is all, it has already taken away. On the other side we have a big transformer power supply. This unit had a little accident. It fell from the truck, literally. So that's why you have these scares here. And the problem is everything is now misaligned and it is too expensive to repair. So that's the lamp unit to erase the cartridges. We have here 5 pairs of fluorescent tubes, 10 tubes in total, And we have 5 power supply starters for these fluorescent tubes here. I think they will go pretty bright. Maybe I'm able to hook them on the mains and see how bright they really are, if they still work after that crash. I just see it's not so easy to directly hook it to the mains. They are made for 120 volts. I have 230 here. Well, that's not a big problem. I have transformers for that. It seems they also installed some current sense transformers here, individually for each of these units. Cool. I don't know why they exactly need to know the current, but in case of a malfunction, it's certainly great to have that. Now let's try to power this up. I want to see how bright it is. It seems to be quite easy. We have a blue and a brown wire. That's for AC input. We have a couple of green, yellow earth wires. And the gray wires here, they come from these current sensors here. We don't need them to play with them. And you see all the brown wires from these ballasts, from the starters here, are tied together, and all the blue wires are tied together. So if I put 120 volts on these wires, I should get a little bit of light. Now I hook that up to my regulated transformer. I set it to about 120 volts and I will switch it on right now. And it is bright. You can't see that on camera, but it is extremely bright. You see how the camera goes black when I switch it off. Let's try it with the room lights off. Yeah, you can see it pretty illuminates the entire room here. I just noticed that my clips have become a little bit warm. They are good for, well, maybe 1 or 2 amps, but here in this case I think I had 3 or maybe 4 amps. No, 4. The fuse would blow at 2.5, but yeah, they are not made to carry high currents, but for a short test it's okay. Inside here you can see the scanner motor that moves the cartridge up and down. It works on this spindle here. On the side here, that's the laser unit. It's a 30 milliwatt red laser that scans from left to right, and the vertical movement is made by the cassette itself. It goes down 1 step, laser reads 1 line, and so on. That's how it works, and that's why this must be aligned very precisely, and that's not the case anymore. I removed all the panels now, except this one here, and there is not an awful lot to see. By the way, you may have asked yourself how you operate this unit. This is the attachment for a bar that holds an LCD monitor with touch interface. That's how it works. That monitor is connected to the PC underneath, which is not here anymore. Then here was the space for the UPS that provided emergency power in case of a power outage. We have a laser unit, I absolutely love these warning stickers here, and the class 3B laser is already relatively powerful. An interesting detail you can see here is that the entire chassis here with the optics is mounted on rubbers, so it can swing freely, and the laser unit has a machined aluminium case. As you can see, it's about 10 millimeters thick or maybe more, so this will gonna be a bit heavy. So we have a big black box with a couple of fans. I assume there are some power supplies and some electronic boards in here. Well, let's have a look inside. Well, that already looks a little bit better. Let's see what we have here. That looks like a serial or parallel interface. It goes from board to board. That's another connector that goes out, probably to the PC. Maybe a serial interface in this case. We have a power supply. 24 volts, 8.5 amp, 12 volt, 10 amp. 600 watts in total. Then we have a big logic board here with some connectors that look like network, but well, it has network capability, but I think network will go from to and from the PC. We have a motor control board. I think that explains what this board is doing. It controls all the many motors we have. Is there some information on this board? Can't see anything. You just see the same cables here. That looks also like, that's the galvo board. That means the galvo motor that spins the mirror to deflect the laser. That's a short form of galvanometer, something with a rotating mirror. Yes, the rest is not clearly labeled. Okay, let's dig a little bit deeper. Oh, there's a nice motor. I think that's the one that moves the cartridges on the table. Yeah, okay. Just in case you have never seen one of these, it's a tilt watch. This dot normally is blue or, I don't know, silver. It has a little metal disc here, and if someone tilts the unit around, this disc will go somewhere in this direction and will be held by 1 or 2 magnets. So it will never fall back again, even if you move the unit into the right orientation. So if this is red, you have a problem. There's another view of how massive this unit is built. That's the transport unit that moves the cartridges down into the mechanism, and that's all cast aluminium. And you see how thick this is. That stuff weighs a ton, literally. I'm not sure, I would say about 500 kilos, the entire unit. I just found out that this unit can be opened quite easily. You only have to open 2 screws, here and here, about in this region here, and then you can lift the entire top. It has gas springs, so it's not a problem. So now we have adjustable slot for different sizes of cassettes, we have a wiper motor that moves this thing here. That's the big motor for the transport of the cassettes. Another one, and again laser unit here, which I will open right now. I opened the laser assembly, and that's what's underneath. This is eventually more interesting than the laser itself. We have two photomultiplier tubes. That's why this board is named PMT board, photomultiplier, so tubes that are extremely sensitive to low light, so they will detect light if they just say there is light or not, and probably how much light there is. They normally work on a relatively high voltage, something about 1000 volts. I don't see any high voltage connections here, so I assume they're generating the high voltage somewhere here. Then going down, there was another cover, and here we see the laser diode with the driver board. Then we have a manual shutter here. It's not a total shutter, it's just a filter that makes the laser a little bit darker. That's to protect the technician when he's doing adjustments and stuff. And after adjusting, you slide this out of the path, so you have the full laser power. So that's a focusing lens, and that's the galvanometer with this moving mirror inside this housing. That's the motor here. It goes to the driver board. And we have a big lens here made to focus the red laser. And here you have the power readings from the laser. In high power mode it's 30 milliwatt, and in low power mode it's 2.5 milliwatts. I think that's the difference of this shutter here. Now let's have a look on this galvo motor assembly. As you can see, that's the mirror that can turn very quickly, and it scans the image from left to right or right to left while the cartridge passes down through the unit. The resolution is about what was it, 500 pixel per inch. So for a large X-ray scan you get about 40 megabyte of data. By the way, I figured out two more functions of motors here. This motor here, if I turn that slides this gripper here forth and back, adjusting for different sizes of cartridges. And the other motor, which is here, opens and closes the gap to grip the cassette firmly. And then we have the other motor down here that lowers the cassette into the unit. So now let's have a look on this photomultiplier tubes. Oops, that was a little bit hard. Wow. Blue. They have a blue filter because the light that is reflected from the cartridge is blue, and you don't want to see the red laser, so they have a blue filter here. And there is another blue filter here with some mirrors and stuff. So the function is like that. You shoot red laser light onto that cartridge and it answers back with blue light. So that's why you need a blue filter here. We have Hamamatsu. I think that's one of the few manufacturers of photomultiplier tubes. There's the date code 2011. They are not very old. And it seems here we have a high voltage power supply module. Output 1000 volt or minus 1000 volt and 2000 microamps or 2 milliamps. It won't kill you, but it will certainly hurt you. We have a couple of input pins here, and we have 2 output pins separated by a large gap, well, 1000 volts. We have capacitors, 35 volts, okay, they are not connected to the high voltage. And another module without any markings. Okay, interesting. So that's about all the interesting stuff here. We have a laser, we have a scanner motor that deflects the laser, we have a massive mechanical construction to move the cartridge. Then we have 2 sensors to get the reflection from the cartridge, convert them into electrical signals. They will get digitized here, stored in the PC, and when everything is done, these lamps go on and erase the cartridge and you can use it again. I just wanted to salvage a couple of the motors, and that happens when you open the wrong screws. I opened the screws from that side, but that only separated the gears, and the whole motor or gear was filled with oil, which drips to the ground right now. That's the other half of the motor, filled with a lot of oil, which is nice, but not on the floor. I opened the top cover. It's about 14 screws, and I figured out another motor that moves that sort of gripper here that clamps the cassette from the side to position it precisely into the slot. Then that's the mechanism that moves the cassettes. It has 2 belts here and this tractor drive here on this side. Would make an interesting tractor track that. Yeah, why not? Maybe the next project. Nice gears. And with all the mess I have to clean up here, I think that's it for today. Thanks for watching, and I will take some parts out now without the camera. Bye. It's always the same. If you know how, it's easy. I have to remove the cover here, the plastic cover, and now these are the screws to remove the motor, and I took this one that held the gearbox together. Well, that's what you have to pay when you have no manual.